Hello YouTube, this is Umils03. So now we're on to lesson 11 within our Python curriculum, and we've already established a lot of good fundamentals and concepts that are really critical for being able to write successful Python programs. What we're going to do in this video is review what we talked about in the previous video, which is our discussion of loops, and we're actually going to talk about and investigate a new type of loop. So we're actually going to have two relatively similar ways for iterating through code and repeating multiple lines of code without needing to write multiple lines of code. So that's essentially the framework that we have going on here. So remember from yesterday that basically the while from last lesson, that basically the while is going to accept a Boolean. And so if we're going to basically have a initialization, so we could call this initialization of a counting variable, or a variable to basically put the while loop in check, okay? And that basically means prevents it from being an infinite loop, okay? So hopefully that makes sense to you with what's going on there. And that was a long comment, but that's what we have going on there, okay? So now what we could do is we could say while of s is less than 24, we could say print of s plus 1, and then we could say s plus equals 3. So what this code is going to do is it's going to take all the values, so it's going to start at s equals 0, and it's going to say 0 less than 24? Yes, so print 0 plus 1. So basically, for s equals 0, it would print 1, okay? And then what we're going to do is we're going to add 3 to the current value of s. So s is going to go from 0 to 3. So when s is equal to 3, we're going to go ahead and print 4. And then you can see what's going on here. When s is equal to 6, we're going to print 7. And basically, this is going to stop. The last time this is going to run is when s is equal to 21. You can see it's going up in multiples of 3 starting at 0. So at s equals 21, it's going to go ahead and print 22, right? So s equals 21 will print 22, but then when s gets to 24, 24 is not less than 24. So then we're going to go ahead and print 1, 4, 7, 10, 13, basically the multiples of 3, but with 1 added onto all of them, starting at basically 1 and going up to 22, because 21 is the last multiple of 3 that satisfied this Boolean, so it was the last value that we could add 1 to. We can also think about basically dividing. So what if we wanted to say something like s is equal to 100, and then we could say, well, let's do subtraction first. While s is greater than 50, we could say something like print, and then we said that in order to concatenate a string, right, we can only concatenate with another string. So we could say string of s for the value of s if we want to print it with s equals, and then we could say s equals s minus 10. So that's sort of the long-handed form, right? So this would be equivalent if you were trying to do basically s minus equals 10. So that would be basically an in-place operator. And so now if you go ahead and run this code, you would get a similar deal. One of the things we said we didn't say in the previous video, but maybe we could have, is that it doesn't have to be an integer that you're changing by. So now what if you go ahead and say s equals 5? Well, s is greater than 1. I'm going to basically decrement s by 0.5 each time. So we're going to be looking at s equals 5, s equals 4.5, s equals 4.0, right? It's going to be all the floating point numbers, okay? And it's going to start at s equals 5 because the first time we go through the loop, we're casting it into a string. But what happens the next time? The int is going to become a float. And then all iterations through the loop after that, we're going to be dealing with a floating point number. And then we're only going to print 1.5, right? Because then after we print 1.5, s is going to go down to 1, and the Boolean's no longer true. But then if we make it while s is greater than or equal to 1, then we will see that last result of s equals 1.0. We could also think about dividing or multiplying. What if we say s is equal to 2, while s is less than or equal to 64? What we could do is print the value of s and then double the value of s each run through the loop, every run through the loop. So now if we go ahead and run this, you could see that s cascades, right? You can see the powers of 2 starting at s equals 2 up to s equals 64. So I think that's kind of neat. And then what you could also do is you could also iterate through a list. So what if you wanted to talk about one of the things we could have brought up earlier is the length of a string. Okay, so we already know the length of a list, right? If we have 9, and then how about false, right? The Boolean false, and then how about st, the 2 letters, right? And then if we say print length of s, len of s, right, really, and then we could say we would get that 3 there. But it turns out you can also have the length of a string. So then we can think of, remember, we can always think of a string as a list of letters or characters, basically. Okay, so now if you go ahead and say s, is equal to Saturday, right? And then if you say print len of s, this is a helpful thing to know. And I think we probably could have or should have brought it up earlier, but this would help give you the length of a string. It's just like the length of a list. And it's just like you could index one of the, just like you could index one of the letters. So if you say s of 3, you would go ahead and get the, you know, the letter at that index position. So that would be that lowercase u. And so you could iterate through an array with this, right? What if you wanted to say t equals, and then you could say turnip or something. And then basically you could have a counting variable like r equals 0. And then you could say, well, r is less than the length of t, because you want to basically iterate through the letters in the string. And you might not know exactly how long the string is, right? You could have it be longer and print all these, right? It would be hard to figure out exactly how many letters long that string is, but you could just say length of t, right? And then you could say print, and then you would say t of r, right? Because it would grab the r index position of the t string. So print that character, and then you would just have to remember to increment by 1. And then if we go ahead and run it, we would get, you know, we would get that turnip, right? You can see those first 6 letters, and then I just added all those random characters just to show you that we don't have to know the length of the string, and this program would still work. So, and then we can also think about a subset. So what if we only wanted to print particular letters, right? What if we only wanted to print turnip, right? So then you could go ahead, instead of saying just, you know, well, r is less than the length of t, you could just say r is less than 6, because then the last value of r that this loop, you know, would run for is r equals 5, and that would correspond to the p, because we said that with lists, you know, with lists, we start at index position 0. So hopefully that makes sense to you. And so, you know, you could also do a different subset. So what if you wanted to see nips or something, right? So then you would start at index position 3. So then if you change this r equals 0 to r equals 3, then you would just be looking at nip, right? But then if you want the s, then you would have to include that index position. So you either have to say r is less than 7, or you could say r is less than or equal to 6, right? Or you could say r is less than 6 or r is equal to 6, right? So you can basically remember a Boolean expression can always be a combination of Boolean expressions using or, and then also not, right? So hopefully you understand what's going on with that, right? So now we would go ahead and get nips, because it's going to include the index position 6. What we're going to talk about is a different kind of loop. We're going to talk about a for each loop, and this is basically what a for each loop is, which is sometimes just called a for loop in Python. Basically, it works a little bit different from the way that a for loop works in other languages, but it's more similar to a for each loop if you've studied Java, okay? And I have the Java videos, so just another reminder that if you want to enhance your skills and learn another programming language, I have about 45 videos that will teach you everything you need to know about Java. It's about 14 or 15 hours of content. So anyway, you have about for each loop here. So basically, it's especially well suited to iterate through lists. Okay, and so basically, it allows us to quickly retrieve every element in a list. So let me show you some while loop architecture that we can use to iterate through a list, and then we can replace it with a for loop, and then you can decide for yourself which one you think is easier. So what we're going to do is we're going to say my list, and we're going to have some elements here. So we're going to say 5, and then the string hey, and then 2.2, and then 5.2, and then true, and then a 9. Okay, so you can see mixed data types in here. And then what we're going to do is we're going to say for t in my list. Basically, this is the architecture of a for each loop. Okay, so we arbitrarily call each element in the list, you know, in my list, t. Then, you know, we can do something with every element simply by referring, you know, to that element as t. So then let me show you exactly what I mean with this, right? But here, let's do this. So let's actually do this with the while loop architecture first. So let's say you wanted to print. So here's the goal, is to print all the elements in the list, okay? One at a time, so one on each line, okay? Because if you could say print of my list, it would just print the list. But let's say you wanted 5, hey, 2.2, 5.2. One of the things you could do is say print my list of 0, print my list of 1, print my list of 2. But we've been building up this understanding of loops, and we said loops are a more efficient way to basically iterate through this, right? And so what you would do is you could basically say index position is 0, and then you would say while index position is less than the length of my list. I think we saw this at the beginning of the video already. And then you could say print my list of index position, right? And then you would just have to increment the index position, okay? So then you can go ahead and do that. And I'm just going to comment out the beginning of that for loop there. And then you would go ahead and see that those elements in the list will be printed, you know, one line at a time. But let's go ahead and replace this. What we're going to do is we're going to say for t in my list. So this arbitrarily references every element in my list, and one at a time it's going to call them t. Okay, so first t is going to be 5, and then t is going to be a string variable hey, and then t is going to be a float variable 2.2, and then t is going to be another float variable 5.2. So then what we're going to do is we're going to say print of t. Okay, that's the only thing we have to write. And then what I'm going to do is I'm going to basically delete this while loop so you can understand that the while loop was able to print the elements in this my list one at a time. And we can delete that now. And we're going to see basically these 2 lines of code that we wrote. Basically, it's what, 5 words? For t in my list, print of t. Okay, so now you're basically going to run main.py and you get the exact same result. So that's an example of how a for each loop could be helpful for iterating through a list. How about what if we want to go ahead and find the sum? Okay, so let's do another example. Let's do another example. Goal, sum the elements in a list. Okay, so basically the technique of 1 will be a while loop, okay, and the technique 2 will be basically a for loop in Python. Okay, so usually, you know, this will be called a Python for loop, okay, which is different from a traditional for loop in Java or C, okay? But I'm just gonna call it, since we're talking in Python, I'm gonna call it a for loop. Okay, so basically we can do it in both directions. So let's say we have values, okay? We're gonna have a list called values, right? And it's gonna have 10, 12, 6, 8, 5, 5, 4, 5, okay? And you could sum those values for yourself, but I don't know what the sum is off the top of my head. What I'm gonna do is I'm gonna start with a sum variable, and I'm gonna have a counter variable. And I'm gonna say, while counter is less than the length of values, what I could do is also, you also want to remember end if statements and while statements, this sort of conditional, right, where you have a Boolean coming in here, you want to end those kinds of statements with a colon, right? And so then what you're going to do, and it's giving us some kind of a PEP thing, I think it might be the parentheses actually. So not too many parentheses, right? Well, counter is less than length of values, you could go ahead and say sum plus equals, you would say values of counter, and then counter has to go up by 1, and then you could go ahead and print the sum, and then we would go ahead and see the sum of those values. So now if we go ahead and run it, we would get 55, and I can go ahead and remove the example from earlier, right? Because we're going to see more examples in this video, but you can go ahead and run it, and you see that the sum of those numbers is 55. So maybe you already calculated that for yourself. But now let's do it with the for loop. So what we're going to do is we're literally just going to say we can remove the counting variable. We don't need that anymore, because what the for loop does is it arbitrarily accesses every element in the list regardless. So you don't need an index position. You don't need a counter variable to keep up with the index position. The for loop is going to go through the whole thing regardless. So now what you do, you still need the sum variable, and obviously you still need the list, but you don't need the while loop anymore. We can still print the sum at the end. Right now, if we try printing the sum, obviously we just print 0. So let's go ahead and update the value of the sum according to the values in values, right? So what you would do is you would say for number in values, you can call it whatever you want, you would say sum equals sum plus number, right? And we said we can go back and forth between the in place operator. So this is equivalent to the in place operator of sum plus or equals number, okay? But this is in place operator, but this is basically, I don't know what you call this, but this is a regular operator or something, but this would be sum is equal to sum plus number, okay? And so basically, I think it doesn't like that we're calling it sum, because maybe Python has a special, you know, maybe they have modules or something for that, so we can call it my sum or something. You don't really, you know, like I've been saying, you can choose whether or not you want to be bothered by these things, right? But we would just go ahead and say my sum, right? And then you can go ahead and run it. And indeed, we would also get the 55. And you can see that this code's shorter, right? You can make it even shorter just by doing that in place operator that we've been talking about. So this is pretty concise, and hopefully that gives you a couple of examples, right? And you can do the same thing that we already talked about with a string, right? So you could say word equals hey, right? And then you can do the same thing for letter in word you could say print of letter, right? This is not that hard. And then you can go ahead, and then that's all there is to it. And then you would go ahead and say, shoot, I accidentally said debug. So now we're going to run hey, right? And then that's exactly what you get. So you get one letter at a time. We can also think about something called range. So what we can do is we can basically have a while loop, okay? So we can have a while loop where we say y equals 0, and then while y is less than 20, we could say print of y, and then y plus equals 1, okay? And then this will obviously, I think we saw this in the last video, and then it goes ahead and print 0 to 19, because 19 is the last value that gets printed. 19 is the last value of y that satisfies this Boolean. We can actually replace this with a for loop, and the way that we do that is by using the range command. So basically, range of x allows us to use a for each loop to basically reference all the elements from 0 to x minus 1. So basically, if you write for t in range of x, basically the for loop will operate for t equals 0, t equals 1, t equals 2, all the way up to t equals x minus 1. So what you could do is you could actually say for y, or let's call it something different. For z in range of 20, you would say print of z. Okay, and now you don't even have to increment z. Okay, the nice thing about for loops is you usually don't have to remember this extra step of incrementing the variable and remembering to do that. Okay, so now you can go ahead. Now I guess what we can do is let's delete the code that printed 0 to 19 and replace it with this other code that I'm saying will have the exact same effect. And now if you go ahead and run it, we get 0 to 19 here in the console. We can do it with a smaller number so we don't have to do as much scrolling, but this would print 0 to 9, because basically if you say for z in range of 10, it goes for z equals 0, z equals 1, z equals 2, all the way up to z equals 9, okay? So it's the same thing as if you had the for loop here. We can bring that back, but these would be equivalent architectures, and you can see the for loop is just a little bit more concise. If you go ahead and have another argument in here, so if you go ahead and say range of 20 and 40, okay? So if you say for x in range of, if you say for t, okay, for t in range of xy, basically this would say t equals x plus 1, t equals x plus 2, all the way up to t equals y minus 1. Okay, so what for z in range of 20 to 40 would do is it would start at z equals 20, and then it would go ahead and increment by 1 every time until just before z equals 40. Okay, so basically adding another input in front of the main one would allow you to start from somewhere other than 0. Okay, so hopefully that makes sense to you. Okay, so then what we can do is we can go ahead and run it. So now this is kind of too long of a range. So let's do 5 to 10, right? Let's for 5 to 10, and then it would go ahead and we're still printing this while loop here, but you can see how this would be quicker, right? And so now what you would do is you'd say for z in range of 5 to 10, and it would print 5, 6, 7, 8, 9. So it'd start, it'd start at 5 and stop just before 10. Okay, and then obviously this would be the same as if you said y equals 5, right? And then, well, y is less than 10, and then print of y, and then y plus equals 1. Okay, the last thing we can do, the last thing is if you have a third input, so adding an input after the main input of range. So if you say range and then something else after x, this would change the increment. Okay, so by default, it's 1, but you could go up by 2 or up by 10 or down by 1 by saying -1. So let me show you what I mean by that real quick. What you could do is you could say for x in range of, basically you could say 60, 80, and 4, and basically this would start at 60 and then basically say it's the same thing as if you said x equals 60. While x is less than 80, print x, and then basically increment x by 4. So you could say print of x, and it would go up by 4 every time. So then it would basically do 60, 64, 68, 72, 76, but then it would stop just before 80, because this is equivalent to if you had said y equals 60 while y is less than 80, print of y, and then y plus equals 4. So this is an example of an increment, and then you could go down in the opposite direction, and then you would see the same thing. So if you go -4, you could go ahead and run it, and you would start at 80, and then you would go down to 64. So we'll see more examples in the next video from Emos03. Thanks for watching, and please subscribe.